Hey there, folks, and welcome back. This is the sixth episode in our Basics of Web Development tutorial series. In this episode, we're going to continue talking about JavaScript and some of the core fundamentals of programming. Last episode, we looked at some if and switch statements along with some logical operators, which let our code make decisions based on specific conditions. Today, we'll look into loops and functions, which will let our code repeat tasks without having to write the same lines of code over and over. Before we dive in, I'm going to remove the code we wrote last episode so that it doesn't keep spamming the console when we run the script. I'll leave it in the version of today's code that I post on GitHub for posterity, but we just don't need it right now. We can leave it in the variables though. So let's dive right into some loops. The first type of loop that we'll talk about is called a for loop. Real quick, I'm just going to write out a for loop that will execute the same block of code 5 times. Let's break this down. We start with the for keyword, followed by an expression inside a set of parentheses, and then some curly brackets. Inside those curly brackets is the code that will run each time the loop executes. The expression inside the parentheses is split into 3 parts separated by semicolons. From left to right, these parts tell the loop where to start, when to stop, and what to do in between each iteration. So in the first part, we declare the variable I and set it equal to 0. I is our loop counter for this loop. Next, we have the condition I is less than 5. As long as this expression evaluates to true, the code inside the loop will continue to run. And then finally, we have I equals I plus 1. This runs after the code inside the curly brackets and increments our counter before the next iteration begins. So, the first time the code reaches this loop, I is declared and set to 0. 0 is less than 5, so the middle expression evaluates to true, and the code inside the for loop runs. After that, we set I equal to I plus 1. Since 0 plus 1 is 1, I is now 1. Next, the code goes back to the beginning of the loop and checks whether it should run again. This time, we skip the declaration and go straight to the middle expression. 1 is still less than 5, so the code runs again. Then we increment I by 1, and it becomes 2. This process continues until I reaches 5, and at that point, I is no longer less than 5, it's equal to 5, so the middle expression evaluates to false. When that happens, JavaScript considers the for loop complete and moves on to whatever code comes after the loop. So let's see it in action. And in the console, we see 5 different lines, each one saying iteration, and then followed by the value of I at that moment, which counts up from 0 to 4. The 3 sub-expressions inside the parentheses aren't limited to just what you see here either. We can change them however we want. For example, I could start I at 2, and then increment it by 2 every time. And now in the console, only 2 lines are logged. This time I starts at 2, then it changes to 4, and then it would change to 6, but since 6 is not less than 5, the loop stops. Feel free to play around with these values and see what happens. Just make sure that your loop always has a way to stop. If I were to change this last part to I equals I minus 2 and decrease I by 2 each time, then I would always be less than 5, and that means the middle condition would never be false, and we'd end up in an infinite loop, infinite loop, infinite loop, infinite loop, infinite loop. If this happens to you in VS Code, you can just press Control plus C or Command plus C on a Mac to force the program to stop. You might need to hit it a couple of times, but it will eventually stop. Now, on the topic of this last part of the expression, there's actually a useful shortcut operator that we can use to add a number to a variable and reassign it at the same time. So instead of writing I equals I plus 2, what we can use instead is I plus equals 2. This does the same exact thing. It increments I by 2. It's just a shorter way to write it. The same idea works with minus equals for subtraction. In fact, when we're incrementing or decrementing I by 1 every time, there's an even shorter option, I plus plus or I minus minus. Using I plus plus, if we look at the results in the console, we can see that it increments I by 1 on each loop iteration. Using I plus plus in a for loop is actually very common. Now, instead of just running a loop a certain number of times, another very common use for for loops is to loop through an array and do something with each element. So we'll change the for loop to start at 0 again, and then we'll stop when I reaches the length of our list array using the length property. And inside the loop, we will just log the element at index I. And when we run it, we see that it loops through the list array and prints each element on a new line, 1, 2, 3, A, B, and true. So I is starting at 0, and this prints the element at index 0, then it increments to 1, prints the element at index 1, and so on. The length property returns the number of elements in the array, which in this case is 6, but since the index starts counting at 0, the 6th element has the index of 5, so when I reaches 6, the loop stops. In addition to the for loop, there's another type of loop we can use called a while loop. So I'll just recreate the same loop to go through the list array, but this time using the while keyword instead of for. So when we run the code, we see that it is doing the same thing that the for loop was doing and logging each element of the list array on a new line. The main difference you'll notice is that inside the parentheses after the while keyword, we only have a condition that tells the loop when to stop. This is essentially the middle part of the for loop expression. Because of that, we declare the j variable outside of the loop, and then we increment j inside the loop. One side effect of this is scope. Since j is declared outside the loop, it can be accessed elsewhere in our code even after the loop runs. With the for loop, the I variable only exists inside the loop itself and it can't be accessed outside of it. This also means that a while loop can use any variable that's already been declared as its condition. We don't necessarily need to create a brand new one just for the loop. So for example, I could use the age variable instead of j. And now when we run the code and look in the console, we see the age variable incrementing from 31 up to 39. One important thing to keep in mind is that this permanently affects the age variable. So if we log age after the loop completes, we see at the bottom that the value of age is now 40. On that final while loop iteration, the age plus plus line incremented age from 39 to 40, and then when the condition checks whether 40 is less than 40, it evaluates to false and it exits the loop. Once again, just like with for loops, make sure something inside your loop changes the variable used in the exit condition so that it will eventually evaluate to false. With while loops, it's a lot easier to forget this and accidentally create an infinite loop because, unlike for loops, updating the variable is not built into the loop structure. For this reason, I try to always use for loops if I can and only use while loops if I absolutely need to. All right, so moving on from loops, let's talk about functions. You can think of a function kind of like a recipe. It's essentially a set of instructions that you can tell your code to follow whenever you want. I'll start by just writing a basic function and then we'll break it down. At first glance, this looks a lot like declaring a variable, but instead of assigning a number or a string, we're assigning a set of instructions. We're using the const keyword followed by the name of the function and an equal sign. And then after that, we have a set of parentheses followed by an arrow made up of an equal sign and a greater than sign, and then a set of curly brackets. Inside those curly brackets is the code that will run when the function is executed. This way of defining a function is called an arrow function because it uses the arrow operator. Before const and let were introduced in 2015, functions were typically declared using the function keyword, which looks a little bit like this. And this is still perfectly valid JavaScript, but just like with variable declarations, using const with arrow functions is generally considered the more modern approach. Now that we've written these functions, let's comment out the console log from our while loop, and let's see what happens when we run it. Well, nothing happens. They didn't do anything. And that's because we haven't actually called either of these functions yet. We've defined them and they exist in our code, but we never told JavaScript to execute the code inside them. But we can do that using the function name followed by a set of parentheses. And now we see the lines being logged by these functions in the console. And this is what makes functions so useful. We can call them as many times as we want, and each time JavaScript will run the entire block of code inside the function every time. So let's talk about these empty sets of parentheses that we keep seeing here. What can we do with those? What can we put inside them? Well, just like a recipe has ingredients, functions can take inputs. These inputs are called parameters. So let's have our function take in two parameters, num1 and num2. And then let's change the console logs so they print num1 on line 1, num2 on line 2, and then we'll do num1 plus num2 on that last line. And if we run the code now, well, we see undefined, undefined, and NaN. That's because when we're calling the function, we're not passing in any values for num1 or num2. So both parameters are undefined. We can fix that by passing values into the function call inside these parentheses here. And here, 6 and 7 are called the arguments. These arguments get assigned to the num1 and num2 parameters in order. And now we see 6, 7, and 13 logged to the console. So now we're passing arguments into our function for it to use as parameters, but what is the function giving back to us? Right now, nothing. It's just logging a few things to the console. To get a value out of the function, we can use the return keyword. So instead of logging all these values inside the function, let's return the result instead. Now this function returns the sum of num1 and num2, but in order to use that value, we need somewhere to store it, and we can do that by assigning the function call to a variable like this. And so here, the value returned by the function call gets stored in the result variable. And then finally, we can log that value to see what it is. And it prints 13. So now we have a complete function that takes in some data, does something with it, and then gives something back to us. Of course, as you've already seen, not all functions need to take anything in, and not all functions need to give anything back, but the options are there. Alrighty, folks, and with that, I'm going to wrap up this episode here. In the next episode, I want to go over some common JavaScript methods, which are essentially functions that come pre-packaged with certain data types like strings and arrays. As always, if you've enjoyed or if you've learned something, please consider showing your support by leaving a like or subscribing. I really do appreciate it. Other than that, I will see you in the next video.